Hello and welcome back to Intro to Programming. So, what we have up here is another framework for an entity relationship diagram. All right, so this is for a school database. These are the 5 tables that I came up with. All right, would there be more tables? Yes, there would be more tables, but again, we're just kind of simplifying it and scaling it down. So here are the 5 tables I came up with. Schools, which would be like primary, middle, high school if you're like a single district. Um, Teachers, classes, students, and then the roster, which kind of lets you know which students are in which classes. So what I'd like you to do is try to come up with the connections between these tables and the keys that would be necessary to implement those connections. So pause the video, give it a shot, and then you can come back and you can see my solution. All right, so let's take a look at my solution. Now, this is not necessarily the only solution, but this is how I decided to draw it up. So I've got my schools table. It has a school ID, which is the unique identifier for the school. I've got one school can have many teachers, but each teacher only works at one school. All right, so there's a teacher ID, which is the unique identifier for the teacher. And then to actually implement this connection, the primary key from the one side of the relationship becomes a foreign key on the many side of the relationship. So this school ID allows the connection to exist between these two tables. Then I said one teacher can have many classes. So again, down here I have a class ID, and then the teacher ID, which was on the one side of this relationship, came down to classes and became a foreign key down here so that this relationship could actually be implemented. Now, classes and students is a many-to-many relationship. One class can have many students. Each student can have many classes. So anytime there's a many-to-many relationship, we have to make this linking table. All right, so roster is serving as my linking table. And what it does is it combines the student ID, which was the primary key over here, and the class ID, which was the primary key over here. And these pairs of numbers create a compound key that gives me sort of unique representations for the students and their classes. All right, and then I also have a roster ID here because, again, every table's got its primary key. So you can think about this as like, oh, student 1's in class 3, student 1's in class 7, student 1's in class 10. All right, student 2 is also in class 3, student 2 is in class 8, student 2 is also in class 10. And it would just give you these combinations, and then they would tie back to these tables so I could know what student those numbers corresponded to and which classes these numbers corresponded to. Now, you may have drawn it together a different way. All right, you may have made the focus like schools and students versus schools and teachers. There are other ways you can set this up. This is just the way that I chose to set it up. All right, so it's not the only solution. There are other solutions, but this is just the way that I set it up. And again, the main idea that you kind of want to internalize is that when you have a one-to-many relationship, the primary key from the one becomes a foreign key in the many. And when you have a many-to-many relationship, all right, we can't actually do that in the database. So we make this intermediate table that sort of links those two things together. And the primary key from both sides of the many-to-many becomes a compound foreign key in this linking table to match everything up. All right. So hopefully this was helpful. Hopefully these are getting a little easier. Because again, pretty soon you're going to be designing your own database. So you've got to have some level of comfort with these diagrams. All right. Now, what we're going to do today is we're going to go a little deeper into SQL. And we're actually going to start by looking at the last question from that first SQL lab. So if you haven't done it, you're in luck because we're about to do it together, and you can get the answer from me. All right, so here is our database. All right, so this is the database that we've been using. These are our 5 tables. And we're going to go back and write some queries. Now, I've said in the past that when you're writing queries, it's really helpful to go to Database Tools and have this relationship diagram open because it shows all the tables and all the columns in one go. And it also shows the relationships, which is going to be really useful for some of the new queries that we're writing today. All right. Now, to create a query, all right, we go to the Create tab up top. We go to Query Design. All right, if the Add Table window pops up on yours, just close it out. And then from this design view, we can either right-click on this and choose SQL View, or we can use the big SQL View button up here. But that'll bring us to a blank screen where we can see, type in our SQL. Now, again, this is really small, so I'm going to do it in a Google Doc and then copy and paste it over. All right, so what I have here in this Google Doc is the query from number 10 on that first lab document you did. All right, and it says select album.album title, comma, song.song name from album, comma, song. All right, so this is the first query that you've seen that takes information from 2 tables. Because on that lab document, the first 9 that you had to do only ever took information from 1 table. So this is the first one that takes it from 2 tables. And with that, you're seeing some different syntax up here. All right, what this means is the first part of this is the table name. The second part of this is the column name. Now, you don't actually have to write it out this long way. The reason this syntax exists is because sometimes 2 tables will have the same column name. So like 2 different tables will have an address field or a zip code field or a phone field or whatever. This lets you specify which one you want. Now, if only one of the tables has an album title, you don't need to do this because it'll be able to figure out which one it wants. If only one of the tables has a song name, you don't need to do this because it'll figure out which one it wants. But if 2 tables had album title, you'd have to specify which album title you wanted. Did you want the one in the album table or did you want the one in the song table? And again, our database doesn't have these repeats, so we don't have to worry about it. But this is the syntax. The table comes first. The column comes second. The table comes first. The column comes second. And you can always write it this way. This will always work, but you really only need to do it when 2 different tables have the same column name. All right, and this lets you kind of tell them apart so that you know which one you're referring to. You know, you can kind of think of it as like a first name and a last name. You know, if I just say Joe, there might be lots of people that are Joe, but if I say Joe Soboleski, I don't know why I chose that name, it's more likely that I'm going to know exactly who I'm talking about. All right, so with that said, let's copy and paste this over to Access. I'm going to copy this. I'm going to bring it over to my query field. I'm going to paste it in. And then I'm going to hit the Run button, or I can right-click and go to Datasheet View, or I can click on Datasheet View here. But when I do, I'll get back some results. And if you look down at the bottom of the database, you'll actually see how many results I got back. And it says that there were 800 results. All right, so 800 results from our query. Well, let me just tell you right now, I did not put in 800 songs. All right, if I open the song table, you're going to see I only put in, I think, 40 songs. And if you look at the album table, I only put in 20 albums. But for some reason, when I ran this query, I got back 800 results. Now, if you're good at mental math, you might say to yourself, well, 800 is 40 times 20. So what's actually happening here? All right, what's happening is when you take information from 2 tables, it doesn't automatically know how the information fits together or how it connects. So what it's doing is it's giving me the song and then it's listing it with every single album in my database. Then it's giving me the next song and listing it with every single album in the database. And then giving me the next song and listing it with every single album in the database because it doesn't actually know how they're connected. All right, so this is obviously a problem because we said the big advantage of the databases was that it could connect these different lists, and it can, but we have to specify that in our code. It doesn't happen automatically. All right, so let's see how we can fix this. So I'm going to go back to my Google Doc so that we can see it. And when we're taking information from more than one table, we have to do what's called a join. We have to join those tables together. All right, and we join tables in the where clause. All right, so this query is going to need a where. Now, this is where that relationship diagram is going to come in really handy. All right, so if we go back to this relationship diagram, we can see that album and song are connected. All right, they have this line connecting them. And they're connected by the field album ID. All right, this table has a column called album ID. This table has a column called album ID. And we know that because the line is connecting those two album IDs, and it's showing us that that's the relationship. Album ID is the primary key here. It's the foreign key down here. It's what allows us to actually connect these tables. So what we have to do in our query is we want, instead of getting back all the matches, we only want to get back the matches where these two numbers are the same. All right. That way we won't get back 800 results. We'll just get back 40 results because we'll only get the ones where the numbers match. All right. So to write that, we can't just say where album ID equals album ID because the computer won't know which one we're talking about. So what we do is we write where album dot album ID. So the album ID from the album table is equal to or matches song dot album ID. So again, both tables have this column album ID. When we write this line here, we're saying only give us back the results where those two numbers match each other. So instead of getting back every combination, we'll just get back the one combination where those numbers match. All right. And if I take this query and I paste it back into my database, all right, so let me go back to SQL view. Let me replace this with the new one and I run it. Now you're going to see that I only get back 40 results. Each song is only showing up once, and it's being matched with the correct album title. All right, and we can go further. All right, let's say we also wanted to know the artist that sang the song. All right, well, we can see that artist is connected to album via artist ID. Both of these tables have an artist ID. That's the line that connects those two. So in our query, we can go back here and we can say, oops, wrong one. I also want to know artist name. And again, I didn't actually need to say artist dot here because there's only one artist name. So it would work regardless, but I'm going to say artist name. I now have to include the artist table in my from. And then if I have a second connection, I need all the connections to be true. So I'm going to say and artist ID. So the artist ID in the artist table has to match or is equal to the artist ID from the album table. So I write that as album.artist ID. So these IDs have to match and these IDs have to match. And if I put this in here and paste it into my SQL view. All right. You'll see that now I'm getting all of that information. I'm getting the artist. All right, there's my artist. There's my song. All right, and there's my album. And remember, this doesn't exist in a table. All right, if I look at my artist table, it's got just the artist. If I look at my album table, it's got just the album info, but it has these numbers that let me tie it back to the artist. Same thing with song, right? This just has songs, but it has these numbers that let me tie it back to the album. And by writing the correct code, I can make it look like there's just one table that has all of the information that I need. All right, there's my album title, there's my song title, there's my artist name. They're all connected and they're all showing up in one spot, even though in the database they're broken up into 3 separate lists. All right, so that's kind of the big thing for today. Like, if there's only one thing you remember, that's the piece that you want to remember, that when we're taking information from multiple tables, we have to join those tables together. It's called joining the tables. We do the join inside of the where clause. All right, so when you're writing your query, it follows the where. And what we specifically do is we set the IDs equal to one another, which is basically saying the ID numbers have to match. And we can tell what we're setting equal to by looking at these lines in our relationship diagram. So we can see to connect these 2 tables, we have to say artist.artistID equals album.artistID. If we wanted to connect these 2 tables, we'd have to say album.albumID equals song.albumID. If we wanted to collect these 2 tables, it would be song.songID equals collection.songID. And last but not least, if we wanted to connect these 2 tables, it would be collection.userID equals user.userID. All right. And we can chain these together. So if I had a query that was using the user table and the album table, I don't get to join them directly. I have to use these 2 tables as sort of a bridge and join them one by one by one by one. All right. So that's sort of the big thing, is joining tables. And this is the syntax that you're going to be using when joining tables. All right. Now, there's a little more that we're going to do today. I want to introduce a few more SQL commands that are going to be useful, and they're going to allow you to write more flexible queries that are more useful in like a real world setting. All right. So the first new keyword that we're going to look at today is the like keyword. All right. And the like keyword is really important because it allows us to do partial matches. All right. And I'm going to give you an example of what I mean by that. All right. So I'm going to write a query here that's select artist name from the artist table. And then I'm going to say where artist name equals, and I'm going to just start with Lady, because Lady Gaga is somebody that's in this database. So I'm going to say where artist name equals Lady. All right. And if I take this and I paste it in here, I'm going to go back to my query 1 here. I'm going to go back to SQL view. I'm going to replace all this. I'm going to paste it. I'm going to run it. And oh, right. I forgot. I can't copy and paste quotes from Google Docs because it goofs it up. So I have to type in the quotes here. All right. So if I run it, you're going to see that I don't get back any results. All right. Nothing comes back, even though if I go to my artist table, I can see that Lady Gaga is right there. All right. So what's happening? Why aren't I getting a result back? All right. The reason I don't get a result back is that when you do equals, it has to match exactly. All right. Unless there's an artist whose name is Laddie or Lady, Laddie, and nothing else, it's not going to return a result. All right. So it's, when you use equal, it's super specific, which isn't very useful, because people misspell things all the time. People only spell part of things all the time. So if we had to have an exact match, it would be really hard to get the information we needed out of the database. All right, so this is where the word like comes in. All right, like effectively replaces the equal sign. So instead of having an equal sign here, I'm going to replace it with the word like. Now, by itself, like doesn't do anything. All right, so let me show you what I mean by that. If I go back to my SQL view here, and I'm just going to replace that equal sign with the word like, just like I did in the Google Doc, and I run this, I still get back no results. All right, for like to actually do something, we have to make use of what are called wildcards. All right, so the wildcard in Microsoft Access is the asterisk. All right, in other databases, it's the percent sign, but in Access, it's the asterisk. So instead of putting in lady, I'm just going to put LA asterisk. And what this is saying is give me back anything that starts with LA. All right, so LA comes first. And then the asterisk basically means I don't care what comes next. So I'm looking for something that starts with LA, but then whatever comes after it, I don't care. Like if it starts with LA, I want it. Otherwise, don't give it to me. All right, so if I take this and I bring it back over to Access and I paste it in, again, I've got to change those quotes, otherwise it's not going to work. You're going to see that now it gives me back Lady Gaga. All right, it's able to find it because Lady Gaga starts with an LA. Now, if I go back here and instead of having it at the back, I have it at the front, all right, that changes the meaning. All right, what that says is I don't care what comes first, but I'm looking for any entry that ends with the letters LA. All right, so anything can come first as long as it ends with an LA. So let me go back here, and then I'm just going to do it in here. I'm just going to move the asterisk to the front. I'm going to hit run, and now you're seeing I get the group Rockapella. All right, Lady Gaga disappeared because she starts with LA but doesn't end with LA, and now I'm getting Rockapella because it ends in LA and the query doesn't care what comes first. It just wants it to end in LA. All right, so that's pretty useful. All right, the last thing that we can do here is we can actually put the asterisk in the front and the back. And what this is saying is I don't care what comes first. I don't care what comes after. If LA exists anywhere in the artist name, I want it returned to me. So there could be nothing in front of it. There could be something in front of it. There could be nothing behind it. There could be something behind it. I don't care if L and A are ever next to each other in the artist name. Oops, I want the result back. So if I go back here to my query and I put an asterisk both in front of LA and behind LA and I run it, you're going to see that I now get back 3 results. Rockapella, because the LA is at the end. Lady Gaga, because the LA is at the start. And then also Justin Timberlake, because there's LA right there, and the query didn't care what was before it, and it didn't care what was after it. All right, so like is super useful to sort of limit your results. All right, this would be the second most important thing from today's video. I mean, don't get me wrong, it's all important, but if we're sort of ranking it, linking tables is number 1, like is number 2, and eventually we're going to get to something called group by, and group by is probably number 3. All right, but before we get to group by, we're going to instead go to something called distinct. And distinct is really easy. You just put it after the word select. So you say select distinct. And let's say that I wanted to select the distinct debut years from artist. Our database doesn't actually have a great example of where you would use distinct. So I'm just going to say select distinct debut year from artist, and I'm going to get rid of the where. All right, so this distinct always comes after select. And what it does is it just eliminates duplicates. All right, so if you have a field and there's a whole bunch of duplicates, and you only want the unique values, the ones that are different from one another. Distinct does two things. It automatically gets rid of the duplicates, and it automatically orders it in an ascending order. All right, so when I run this query, you're going to see that there are no duplicate years, and they're going to automatically be in order. All right, so if I go back to my query here, I go to paste this in and run it. All right, the years are automatically in order. I didn't do that. All right, I didn't write an order by command. It just automatically put them in order. And you're also going to notice that there are no duplicates. So every year that's listed is unique. All right, and that's not, if you look in the artist table, there are some duplicate debut years. All right, so like here's the artist table. There's a 2008. There's another 2008. So there are duplicates. Distinct removes any duplicates and just gives you the unique values. So again, not super useful in our database, but it is something that's out there and can be useful. All right. Now, the next thing that we're going to look at is another shortcut command. All right. So last class we looked at between, and we saw that between could be a nice way to sort of save typing. Instead of having to say, where, let's just say debut year is greater than or equal to 2000 and debut year is less than or equal to 2005. All right, so instead of doing this, where debut year is greater than or equal to 2005 and debut year is less than or equal to 2010, let's just say. All right, we saw that we could use the word between and save ourselves some typing. We could just say where debut year is between 2005 and 2010 and make our query a little shorter. All right. Well, there's another kind of shortcut word called in. All right. And in can save you some typing when you were going to do a whole lot of or statements. All right. So let's say I was going to say select F name from the user table. And I might say, where F name equals Mr., because there's a bunch of Misters in our table, or F name equals Mrs., or F name equals, what's a good F name to pick here? We'll use my name, David. All right. This will go through and it'll find all of the Misters, all of the Misses, all of the Davids. And if I take this query and I copy and paste it over to my database, so let me copy and paste it over to my database and I run this. All right. Oh, again, I keep forgetting that I can't copy and paste quotes over. All right, so let me put those quotes back in using Access. And let me run this now. All right, it'll tell me that there's one David and there's 1, 2, 3, 4, 5, 6, 7, 8 Misters. It must not be Mrs. It must be just Miss. So let's get rid of the Misses and just change it to Miss. All right, and now, all right, so now I'm getting back a David, I'm getting back a Mister, I'm getting a bunch of Misses back, but I'm getting back all of these results. All right, but when I wrote it, I had to keep saying F name equals or F name equals or F name equals. All right. In is a shortcut. All right. It kind of saves you some typing. I can say where F name in, and then I do a left parenthesis, and I list all the options that I want to check for. So I can say Mr. Again, it's in quotes because it was text. I could say Miss, and again, put it in quotes because it's text. And then I could say David, and again, put it in quotes because it's text. All right. And this is just a shorter way of writing it, but it essentially means where fname equals Mr. or fname equals Miss or fname equals David. All right. It's just a shortcut way of writing it to save you, the programmer, a little time and energy. Now, something I should note is the only reason there are quotes here is because I'm doing text. All right. If these were dates, I would be using hashtags, because remember, hashtags are for dates. So I'd have a hashtag at the front of the date, and I'd have a hashtag at the end of the date. And if there were numbers, I wouldn't be putting anything around them at all. All right. Numbers don't get quotes, they don't get hashtags. You just put the number in all by itself. So again, I'm using quotes here because it's text. It's not that in requires quotes. If it's text, you need quotes. If it's a date, you need hashtags. If it's numbers, you don't use anything. What it does need is these parentheses, and it does want each one to be separated by a comma. All right. But again, I can take this, I can copy and paste it over here. And the annoying part is I'm going to have to change those commas again. All right. But you will see that it does the same exact thing. It's just a quicker, easier way to write it. So if you know these extra command words like between and in, it just makes your life easier because it shortens up the query. All right, so there's a shortened version of the same exact results. All right, so again, not a huge thing, but a nice sort of tool to have in your back pocket because it does shorten up the queries that you're sometimes writing. All right, now the very last one that we're going to do is what's called a group by query. All right, and a group by query is what allows us to do calculations inside of our database. So let's say that I wanted to go through my database and find the average rating for each song. All right, so in this collection table, you'll see that it tells me the user that owns the song, what song they own, and what rating they've given that song. So maybe I want to go through and find the average rating for each song. Well, to do that, I would have to group all of the song ones together. All right, so there's a song one, there's a song one, there's another song one. I would have to go through and group all of those together and then calculate an average using just those ratings. All right, and that's what group by allows us to do. It allows us to organize our data into groups and then perform a calculation on that group. All right, and the calculation can be things like adding. So if you want to add everything in a group, it can be something like averaging. If you want to average everything in a group, it can be something like counting. If you just want to count how many things end up in each group, like how many people rated song one, how many people rated song two, and so on and so forth, I could just count the ratings. All right, so let's see what that looks like. All right, so if I go back here, if I want to do a group by query, I could say something like select song ID, comma, and then instead of saying rating, what I say is it looks a little like Google Sheets or Excel. I say AVG, and then I do a left parenthesis, and I put rating inside of that. So I'm saying I don't want just the raw ratings. I want to calculate an average rating. All right, from the collection table. Right, and then this is the important part, and this is the new part. I have to say group by song ID. And what that is telling the query, it's saying, hey, take those song IDs and form groups with them. So like all the ones become a group, all the twos become a group, all the threes become a group, and then calculate an average, a different average for each of those groups. So if I take this and I copy and paste it over to Access, and I run this, all right, some of these have like little hashtags. That's just because the column's not wide enough. If you expand out the column, you'll see the full number, and it's calculating an average. All right, it's telling me the average rating for song 1 was 4.16. The average rating for song 2 was 4.3. The average rating for song 40 was 3.6. So it's going through and it's making a group out of each song number, and then it's calculating an average for just that group. All right, and again, average isn't the only thing I can do. All right, I could go here and instead of average, I could change this to count. All right, and if I change it to count, all right, so let me change it to count over here. It's counting how many people rated it. So it's still making those groups, but now it's saying, oh, there were 12 people that rated song 1. There are 9 people that rated song 3. There are 8 people that rated song 14. All right. And I don't just have to do it by song ID. All right. This also has user ID in it. So I could say, all right, select user ID, the count of the rating from collection. And now I'm going to group by user ID. If I take this and paste it into my database, right, now you're going to see it's giving me the user ID and it's counting how many ratings that person did. So person 1 did 8 ratings. Person 7 did 12 ratings. Person 15 did 10 ratings. Person 20 did 7 ratings. All right, so it's doing this calculation and it's making a group out of each of these user IDs. Now, sometimes you're going to do these calculations. So let me go back and let's change this back to average rating. And we're going to go back to song ID. And we're going to go back to song ID. Sometimes you only want back, like imagine we only wanted to know the hot songs. So we only wanted to know songs that had a really high rating. All right. Normally you'd think to yourself, oh, if I want to limit the results, I would make a where clause. And normally you'd be right. Unfortunately, when you're limiting your results of a calculation, all right, so not like a normal column, but a calculation like we're doing here, instead of using where, we have to use the word having, all right? And then we can say having average rating, and we could pick a number like greater than 4.3 or something, all right? But if you're limiting, if you're doing one of these greater than, less than, greater than or equal to, less than or equal to on a calculation, all right, so not just a regular column, but a calculation, the word that you have to use is having as opposed to where, all right? But if I take this query and paste it in my database, you're going to see that now I only get back the songs that have a really high rating, above 4.3. All right, so if you were actually running like a real music database, you could write a query like this that tells you what the most popular songs are. All right, you don't have to like separately store that. You can create that number live and it can constantly update, because when I rerun that query, if the data's changed, I'll get new averages because everything is happening on demand. All right, so the group by is a really powerful and useful function when you want to start analyzing information in your database. Now, you might be saying to yourself, song ID, that's kind of annoying. Can't we get the song name? Yeah, we can, all right? But getting the song name is going to mean linking our tables together, all right? So we've got the collection and the song table. If we want to link those tables together, we can see that they're linked by song ID. So what I might do is I might go here and I say, all right, instead of getting song ID, let me get song name, because that's what I really want. I'm still going to calculate the average rating. All right, it's going to come from the collection table, but the song name is going to come from the song table, so I need both of those. All right, I'm not going to group by song ID anymore. I'm going to group by song name. So let me put that there. And then the where statement actually has to go between the from and the group by. So again, order matters here. So we can go select from where group by having average. So where goes in between the from and the group by. Right? If you try to put it after, the query is not going to run. All right, so as far as what I'm typing in my where, again, these are connected by song ID. So I want to say song.song ID equals collection.song ID. All right, so song.song ID equals collection.song ID. All right, and if I take this whole big long query now, and I copy and paste this into my database, it'll give me those same results, but now it'll give me the song names instead of the song ID numbers, which aren't very useful. But now I can see, what are the hot songs in my database. All right, and if I wanted to also know the album and the artist, I could link those other tables in. But right now, we're just going to stop here. All right, so that's kind of like the next level of SQL. All right, we did a lot right there. We talked about linking tables. We talked about the like command. We talked about the distinct command. We talked about the in command. And then we looked at group by. So this is sort of the next level of SQL where we're starting to do sort of more complicated coding inside of our database. So what you're going to do today is there's a second SQL lab. Now, you shouldn't do this until you finished the first one. So if you haven't finished the first one, finish that first. But once you finish it, then what you've got here is sort of the next level of SQL. Now, at the top of this, I give you some examples because, again, these are more complicated. So I give you an in example so that you can see that and have it as a reference. I give you a like example so you can see it and have it as a reference. I give you a distinct example so you can see and have it as a reference. And then I give you a group by example because that's probably the most complicated of all of them. All right, so the exercises here are going to require different things. They're very similar to the last one. They're just more complicated. So it says write a query that will list all the songs and the albums that they are on. Right? That means you're taking information from two tables and you're going to have to link them together. All right, this one involves using distinct. This one involves the like command and linking tables together. So you're going to have to do both of those. This involves the in command. And then there's two that involve sort of the group by command. So work through these. If you need to, go back, watch the part of the video that deals with linking tables, or watch the part of the video that does distinct or like or whatever. But you want to work on these. And again, you're going to test them in Access. And then when you know they're working, copy and paste them over here. All right. So I hope this was helpful. Best of luck. And as always, reach out if you have any questions. All right. Bye.